Okay, you guys, so now what we're going to do is we're going to shift gears. Up to this point, I have given you the equations, and then we drew data from it, and then from that data we were able to generate graphs. What's different about the next videos in several different locations is I'm not giving you the equation. I'm actually asking you to find it. All right, so given this picture, what's the linear equation that might fit it? Right? Given this picture, what's the linear equation that fits it? Given this table of data, what's the linear equation that fits it? So we're actually reversing ourselves. Challenge is we have three forms, right? We have the general form, ax plus by equals c. We have the nice famous y equals mx plus b, the slope-intercept form. And then we have the not so famous but equally spectacular point-slope form. So we have three to work with. So when I asked you to find the linear equation, which one do you use, right, now becomes a matter of choice. Sometimes I'll ask you directly, and then in this case I'm just saying find one. So I'm giving you actually the option. So to kind of narrow down our choices here, let me go ahead and rule out this one is very, very hard to use. As we saw, to graph we actually change it to another form. So even if we try to curve fit or do some linear equation modeling, right, it's usually not the one that we start with. So we're going to cross that out right away. So now, right, I went from 3 options to 2. So now we got to figure out, well, which one of these 2 options do I use? Well, again, the key is that it's given, right? So what's given here, right, is the slope and the y-intercept. So that is what I need to curve fit. So if I have the slope, or I can find it, and I'm seeing the y-intercept, this would be the way to go. Excuse me. However, this one, right, is called the point slope, right? So again, I can find the slope, or it's given to me, and then this is really cool because it's just saying point slope, and I actually can use any point that I want. And to show you the strength of this guy, if you would, right, how many points are there on a line? Well, we know there's an infinite number of them. And that is really cool because the point slope form is saying you could use any solution point you want. Let that be your x1 and your y1 and find your slope and you're off to the races. This guy, for as cool as it is kind of very restricting, right? Because what data point does it want? It exclusively, without any doubt, needs you to have the y-intercept. You need to know what that y-intercept right is away. Otherwise, this is a useless form. So it turns out this guy's a little stronger, even though this guy's a little nicer to use. But this guy's strong because you need any point will do. Pick your point. You got a right answer. All right, and maybe that's what makes students a little squeamish because they always want to know what's the answer. And if you use this one, there's an infinite number of possible answers because there's an infinite number of points. I think that's cool. Perhaps, students think it's not cool, which is why they like this one. I don't know. All right. At any rate, all right. So let's go ahead and take a look at our situation. So the first one, I know it's a little small, but what you're basically looking at, right, is the number of units being sold and the cost in thousands of dollars. So let me kind of make that a little bigger. So that's what you're essentially looking at for, right? We got 50, 100, 150, 200, and 250. Just my printer's it's been acting up on me. And then on this side we have 100, 200, 300, 400, 500. So when I'm looking at this, the first thing we should do so I can decide which one of these 2 that I have is really, do I have the y-intercept? Can I clearly see a y-intercept? And for this first graph, the answer is yes, right? That y-intercept looks like it's clearly happening at 0, 50. So this tells me that the form I want to fit is the good old y equals mx plus b. And I'm halfway there. We actually know what b is. So now what we have to do is figure out what is the slope. And of course, to find the slope, again, the data point here, this is at 150, 200. The next data point is at 300, 150. And this last data point is happening at 450, 200. All right, so there's my data point, and you can find your slope a couple of ways. I haven't used it yet. How about I use my slope formula, right? So from here to here, right, if this is x1 and y1 and x2 and y2, What's the slope? Well, we're going to go y2 minus y1 over x2 minus x1. It really doesn't matter which ordered pair you have, because the slope, right, the reason why we have a nice line is because the slope's constant. So pick any two. I picked these two. So my y2 is 200, my y1 is 50, my x2 is 150, and my x1 is 0. All right, so let me make sure. 200 minus 50, 150 minus 0. All right, and so we're good to go there. Something doesn't look right. Hold on. Did I graph that 150? This is 100, you guys. I'm sorry. So that should be a 100. I knew something was wrong. Something was off. So this is basically, that's a 100. 50, 100, 150. I mislabeled it. So that's a 100. So what we get is 50 over 150, and that reduces to 1/3. So there's my slope. So I now have that. Plug it in, y equals 1/3 x plus 50, and this is basically the equation that would match all those data points. Right? If we graph that equation, it would go right through all the data that was given, including the one that I finally got right, 150, 100. So there you go. All right, now the next one presents a little bit of a challenge, all right, because I can actually see the y-intercept. It's sitting right there, but I can't really understand where it's at, right? I mean, is that, is that negative 3/4? Is that negative 2/3? Is it negative, 4/5? I don't know exactly what it is. So in terms of making my decisions, the y-intercept, even though it's visible, is not clear. So what form do we want to use? We want to use this one right here. We actually want to use the good old y minus y1 equals m minus x1. So what do I need to find? I need to find a point, and I need to find my slope. Of course, in order to find a slope, I need 2 points. So why don't we go ahead and do that? So when I look at this real closely, right there, looks like where I have a nice coming together of the data. So that's a -4, 2, looks like one of my data points. And if you want to, we could even use that, right? That data point right there looks like it's occurring at -1, 0. It is an intercept, but it's the x-intercept, right? We need the y-intercept. So what's my slope? Well, again, x1, or how about I just count it, right? We're going to go down 2, 1, 2, 3, and over 4. So my slope is -2 over 4. It's -1/2. So there's part of my story, right? My slope is -1/2. What about x1 and y1? Well, I already labeled it right there, right? So x1 and y1, I called that -4 and 2. Could I have used this one? Could I have used that point? Could I have used that point? Yes, yes, and yes. You could use any point that's on the line, but I'm not going to make this too difficult. I've already identified x1 and y1 as -4, 2. All I got to do is dump things in the formula. We get y minus 2, let me put it in parentheses, equals my slope, -1/2, x minus -4. So all I did is replace y1 with 2, I replaced my slope with a -1/2, and I replaced my x1 with a -4, because those are the values that I see. Cleaning this up, this will probably be the answer in the back of the book. It'll probably look like that. Y minus 2 equals -1/2 x plus 4. I'm only asking for a linear equation, and I gave you one. I gave you the one that's in point slope form. And there you have it. All right, so how about, this is already a little lengthy. As you can see, there's a lot of details in it, a lot of decisions that need to be made. Right, I'm going to cut another video, and we'll redo this, right, not with a picture, but with actual paired data. All right, see you guys in the next video.